Yeah.
Alrighty. Happy Tuesday. Alrighty. So feeling a little better, which is really good. Not 100%, but on the mend. I saw the regular doctor, and he's like, "Oh, that other stuff the other doctor's having you take might make this bad. You should take this other stuff because you're taking that stuff." I'm like, I have so many pills now. But we're getting there. We're getting there. So it's helping. Yeah, happy Valentine's Day. We're here doing Java. Hey, you know what we could do? There's some cool ASCII art stuff. ASCII art rows. Let's do this. You can make a program to print out a rose. All right, hey guys, time to settle down. So why don't we we could make a little ASCII art to print out a rose if we wanted, and call that our Java Valentine's Day. Does that sound exciting? Yeah. I just need to find the right. Maybe it's not an image. I just want the actual website, right? ASCII art rose. ASCIIart.eu. Here we go. Look at that. Those are fun. So we just like throw this in a little print program, right? All right, so first we got to talk about the lab, our rock, paper, scissors lab. And then we'll move on to the new stuff. All right, someone's calling you out on Twitch for being loud. I think they know who it is. Probably Frank. All right, so I'll throw this in here. So we want like a big print block here, right? So we can do these cool triple quotes to do a big printed block. I think that ought to give us what we want here. Let's give it a shot. Might look a little funny, but it might be close. Look at that. Happy Valentine's Day, y'all. We got our rose for rock, paper, scissors. That's like the secret, if you play rose, you win. No? I don't know. Yeah, so we didn't do rock, paper, scissors, lizard, Spock. We could add that one in with not too much more trouble here. So just a couple more conditions. So I heard on the radio, because I'm a giant nerd, and I listen to NPR on the radio instead of music. There was a flower shop in New York, and they're complaining that they had to buy roses at wholesale for $1 to $3 a rose, and they're selling a dozen of them for $120. I'm like, and you're complaining that the price of roses went up, and you're selling them for $120, and you bought them for like $36. What's the? I mean, yeah, they have to go and do some trimming and put them in a vase and make them look pretty, but like,
nobody's going to buy it that much.
No, they said they sold out. They were getting an order every 2 minutes or something. It's like ridiculous. My wife would be mad at me. I'm not buying her a dozen roses on Valentine's Day, but she appreciates that. She's thrifty as well. So roses are great. You just don't buy them on Valentine's Day because they're triple the price. And if I do that, she's like, Eric, you're stupid. ChatGPT rose? I mean, we could ask. Draw an ASCII art rose. ChatGPT Plus. There we go. Draw art rose. See if it can get us one here.
I'm not going to lie, it's been helping me with a lot of examples.
It is. That's fantastic. Just asking for more examples. That's not a rose.
A heart?
Okay, a heart. How about a rose? You're right. Nope, still not a rose. That should be more recognizable as a rose. Let's see.
Yeah, ask us to draw some Among Us. I think by game it's going to be a rose too.
That's a lion. That's a lion. All right, Chad is failing here, friends. Or ChatGPT.
Draw Among Us.
Draw an Among Us?
Yeah.
I want the rose first. No,
oh my God! It is Among Us.
All right, we're about to be all replaced by robots. It's okay. This is good. This is what we want. It's just this is just ASCII here. There's no code. Well, it's just picking a language. None of these are actually languages. Like it found a character. It's like, oh, it probably is this language here.
It's like the beginning of it's the beginning of the.
All right. Nope, that did not. Oh, let's try the new Bing. Bing is supposed to be better, right?
Oh yeah.
It. That's not no. Do I draw our rows? This okay? This one has links. This is not. We're not. I didn't get on their short list here, but Bing's trying to. They're going to incorporate their technology. Anyway, our lab stuff, right? We've got. This is fun. I'm going to leave the rows here for fun, right? Because we should. I did steal that from here, though, right? We need to make sure we cite our source here. Okay. So to play the game, we left off. We have get the player's throw, get the computer's throw, and do our countdown to see who wins. So for the computer's throw, we said let's do a random number, 1 to 3. This works out pretty well. If the number's 1, then you're rock. Right? Return rock. Else if the number 1 to 3 is a 2, we're going to return paper. Paper. There we go. And then you might think else if number's 3, return something, but if it's not a 1 and it's not a 2, it's got to be the 3, right? We don't need to check another thing here. This can just be an else here to return scissors. Right? So a couple of people had some trouble and they said, hey, I had my else if here, numbers 1 to 3 equals a 3, and they didn't have a return statement here, and Java yelled at them. And Java says, with this little red line here, missing return statement. Because as smart as Java is, it doesn't know that it will be a 1, 2, or 3. It says, oh, if it's a 1, you get this. If it's 2, you get this. If it's a 3, you get this. What if it's not a 1, 2, or 3, dummy? Well, we don't know. But we know it's a 1 to 3 because that's what we told it to do, but Java doesn't understand that. So if you don't have the if there, you don't need that last return statement. A couple people just had like just a blank here. They'd say just return blank. That would work, but it's more typing than you need to do, right? Back to my friend, thank you for donating those bits to the Student Scholarship Fund at the University of Michigan Dearborn College of Engineering and Computer Science. You're a legend, sir. That's twice in a day. My goodness, the internet's a weird place. Such cool people. All right, so we should be able to get a random number, right? Awesome. This will be rock, paper, scissors for the computer. Now, for the player, right, the idea was we wanted to ask them to enter something, make sure they gave us something that was rock, paper, scissors. If they didn't give us something that was rock, paper, scissors, tell them again to enter rock, paper, scissors, right, that little validation loop, and then when we're done, give back the right answer. So a couple ways of doing that, right? I like, so I'm going to have a string for throw here. No, I can't use throw, that's a reserved word, sorry. Player throw, how about that? And I'm going to set it to blank to start, because I don't want to have to type this all over again. So I'm going to say while my player's throw equals ignore case rock. So I want if it's not rock, right, and it's not paper, and it's not scissors. Again, a couple different ways you could go about that. I think we looked at a couple of those last time we did these loops here. So rock, paper, and scissors. So in this case, if it's not rock, and it's not paper, and it's not scissors. So if it is rock, that's true. A not true makes that false. False and something is always false. The loop doesn't run. We're done. Right? So if any of these becomes true, the not makes it false, and then the whole thing stops. That's why we're anding these together here. You know, a couple different ways to do your loops, but I like this one here. It works out relatively well. So I know that it's not going to equal one of those, right? Because I set it to blank. So sure, some people do a do loop. That's fine. I hate do loops because they have a semicolon. That's literally the entire reason I hate them. So if you didn't know the validation loop, that's okay. I think I mentioned it, but maybe not. That's just good practice. You know, we don't get to forget any of the things we've done before. We're just going to keep on building on these tools and techniques and tips and things. So then we can ask them, hey, enter, or what, I don't know, pick your throw, or I don't know, enter rock, paper, or scissors. And then we'll go set their choice, right? We'll set player's throw, player throw equal to, and we need the keyboard, the scanner object here, right? So inside our method, scanner keyboard is a new scanner, given system.in, we'll make that the keyboard.next line, like we do. Next line. Great. If it's not rock, and it's not paper, and it's not scissors, the loop runs again. Eventually, the loop will stop, hopefully, because the user enters the right thing. And as many tries as it takes them, great. Eventually, when they do enter one of those values, the loop stops and we return the value. So I made sure that I got something that is valid from the player. Right? That's the idea with this one here. And then to display the countdown and winner, there's a couple ways. I think we talked about this in chat. If you're on Discord, it's a great place to be. If not, that's okay. You don't have to use it, but it works out much better than those online discussion forums, because those are like 1990s technology. Pretty sure they were around in the 90s, at least early 2000s. We had those discussion forums, and they haven't changed them at all. Like, I mean, it's been 20 years. We could, I don't know. Okay. So I like Discord. So we can say what the player picked. We can say what the computer picked. Sure. It's probably nice to tell them what the computer picked. Why not? Because otherwise you're going to be a little confused. So we'll say computer picked and the computer's throw. And that's just a double click to highlight a word. A triple click highlights the entire line. So you got to be careful how fast you click. But 2 clicks will highlight a word. 3 will highlight the whole line. And then copy and paste. Control C, Control V. It'll be better at my shortcut. Sorry. At one point I had a tool that would like pop up the keys I was typing so you could see all the shortcuts. And then I went and logged into something and it showed my password too. And it's really dumb and stupid. And I had to go change my password and then stop using that tool because I thought it was just for the shortcuts. But no, it was for everything I typed would pop up. I learned that pretty quick. So cool. So 3 different things happen to rock, paper, scissors, right? Either you win, you lose, or you draw, right? The draw case is probably the easiest one to check for because we match. I don't need to say, hey, is the player rock and the computer rock? I can say, if the player and the computer match, it's a draw. I don't care which one they were here. It's a draw. So that's pretty quick. I can say if my player's throw equals ignoring case the computer's throw. Tie or draw or something, right? If it wasn't a draw, now this is a little longer. We can look at the win cases or we can look at the lose cases first. But there's 3 of them. It's not too bad. And just like you would say in English, if the player threw rock and the computer threw scissors, the player wins, right? So we'll check that. If the player's throw equals rock, right, and the computer's throw equals scissors, that's a win, right? If that's true, that's one win condition. Now we could do a bunch of these, or we could be a little smarter here and add an or and say, what's another way we could win? This way, or this way, or this way. There's 3 ways to win, right? So I'll copy all this and change it in here. So if we are paper and the computer is rock, that's a win, right? Or if we are scissors and the computer is paper, we win. If any one of the 3 of those is true, right, because this and this, or this and this, or this and this, right, any one of those 3 combinations is true, the whole thing is true because we're oring them together with our ors here. Oring sounds like a funny word. Is that even a real word? If I hit you with an or, am I oring you? No, that's assault. Sorry. So this was a win, right? You win. And now we could go and list out all the loss conditions here, or we know if you didn't win and you didn't tie, you must have lost, right? And there's only so many things that can happen. So this can just be an else. Else you lose, right? That's it. That's all that happens. Let's give it a try. Yeah.
For some reason, I thought we had to count like every time each game. What you do is like a certain number of times. There, the program dictates the winner after playing so many times.
So like the best of 3 or best of 5 or best of, that's cool. Yeah, I mean that's fun too. I don't know if I would actually want to play 7 times though, but we could.
I just didn't know how to do that.
Yeah, I mean, we could look at something like that. Uh-oh, it ran, but it didn't do anything. Where's my get players throw? Keyboard next line. It didn't get anything. That's interesting. If it does not equal rock, and it doesn't equal paper, and it doesn't equal scissors. I think my line, oh, this, I'm backwards here. This is wrong. Man, I spent all that time talking about it. So this ran without ever doing anything. It never asked us to pick. So something's wrong here. So if it's not rock, and it's not paper. Oh, I missed an and here, or a not. That's what it is. So I have my not here, I have my not here, and this says and player is equal to scissors. Oops, that should be not player equals scissors. That's a bad copy paste on my part. Let's try it again. Maybe now it'll ask us. Okay, now enter rock, paper, scissors. What do you want to play?
Rock.
Rock. Rock is the best. We win. Look at that. Let's do it again. What should we play? Scissors. SCISSORS. Oh, we'll draw. So it's kind of annoying to have to hit run every time, isn't it? Wouldn't it be nice if we just put this in a loop? Right? So like we can say string for play again. Player play again is a Y. And while play again equals ignoring case Y. You do this whole thing. And at the end, we'll ask if they want to play again. Do you to play again? Play again? Oh, goodness. All right. The page up and page down keys are next to my arrow keys. I'm always bad at that. So I don't have the keyboard object here, right? So I got to make another one. Scanner keyboard. Build a new scanner. Given system.in. Not a quote. System.in. Okay. And then we can say play again. Nope, play again. Player again. Play again. Keyboard, the next line. There we go. Right, so that way we can just play again with like a Y or an N, and we should probably suggest that, right? I always say you should suggest that. Y/N. There we go. Oh, no, rerun. Stop. Run it again. All right, here we go. Enter rock, paper, scissors. We did paper, we did scissors, and we did rock. So let's try paper. Oh, we tied. You want to play again? Yes. What should we do? Paper again. Oh, we lose. Should we play again? Paper again. You win. Play again? Sure. Rock. We win. Yes. Rock. We draw. Yes. Rock. You lose. So apparently they did a study here, and what was it? If you win, you're supposed to change, but if you lose, you're supposed to stay the same, and you're more likely to win because other people, when they lose, are likely to change. And some whole, it's like it's a mind game. It's not really chance, right? So you can statistically improve your chance of winning in a best of 5 scenario, that sort of way. Sure. And anything other than a yes, right? Our whole program should end. So if we wanted to count how many times we won, lost, or drew, this display countdown and winner is not enough because it's not going to count anything for us. It's not going to tell us if we won, lost, or drew. It's just spitting something out on the screen, right? The method doesn't return any values. We'd have to return something, and then we can look at the value that was returned and start counting it. Hey, if I got returned a win, or if I got returned a loss, or if I got returned a draw, I can start adding that to a count of win, losses, and draws. And you do something like that. That's an option. And then this could be like a for loop. Hey, do you want to do a best of 7 game here? But at that point, we're pretty sad. It's Valentine's Day, and we're playing rock, paper, scissors with our computer. So let's not do that. It did give us a rose. You're right. You know, how sweet of the computer. That's how much it likes us. So we could make it say paper covers rock, rock beats scissors, if we were more specific in our cases here. We weren't specific, so we just get a generic you win. If you wanted, you could say, hey, in this first case, you could print out rock smashes scissors. Else if, this case, paper covers rock. Else if, scissors cuts paper. Else you lose. Or, again, each of those flipped where the computer beats us. You got options. So either way should make it work. All right, Torch Bat wants a dad joke. There we go. We'll do that, and then we'll move on to the new stuff. This makes sense for the lab? Cool. Let's see what we got here. Those were the dad jokes. You didn't want the knock-knock ones. What do you call somebody with no... Wait. What do you call someone with no body and no nose? Nobody knows. Sure. Okay. I've seen better. I guess they're meant to be bad puns, right? Oh, this one's my favorite one. This one's a chemistry joke. I don't trust atoms. They make everything up.
Oh, I remember that one.
That's like the best one. That one's quality there. All right. So we're going to move on to new stuff. So far, everything we've done is kind of built on itself, added some new ideas here. This next chapter is going to feel like going way out to left field. It's a very different departure to what we have been doing, but it's foundational to how we program in modern programming languages with object-oriented programming. It's a different style, a different way of thinking about things. It's a lot of fun. So let's take a look. Let me go grab the book here. Here we go. So we're moving into chapter 5, objects and classes. And this is a big chapter. We're only getting through about 1 through 4 tonight. And then we'll come back for the other pieces next week, finish up some of this stuff, talk about some additional things that aren't in the book when it comes to classes. A lot of this stuff you'll hit, if you continue on and take the next course, Object-Oriented Programming in Java. So we just kind of touch on some of these more advanced topics, but we're going to make use of them when we get to our graphical user interface programming. So if we don't talk about them at all, it doesn't make any sense when we use them later. So we'll talk about them at a kind of a high level, and then you can really dive deep next semester if you do continue on. We go from there. So the main idea here with object-oriented programming is that it's natural for humans to think of things as objects, right? So if I tell you a chair, everyone's probably envisioning a different kind of chair. You might be thinking about the chair that you're sitting in. You might be thinking about your dining room chair. You might be thinking about a lazy boy chair, right? There's all sorts of different types of chairs, but they're all chairs, right? So when we think about objects in code, it's a similar idea. There's a definition for what does this type look like? What's the blueprint? How do we build one of these things? But each one gets its own set of attributes that make it unique. So I can make a chair in Java, and I can say, hey, this chair is brown and is covered in leather and has 4 legs and weighs, 150 pounds. Lazy boy chairs are heavy, right? These things are hard to move around the house. Sure. Or I could say, hey, this chair has 5 legs with wheels, it is purple, and it goes up and down. Right? You have different properties, different attributes of each of these nouns. So similar to like a bottle, right? A bottle, different attributes of bottle, probably say the size of the bottle, right? The kind of fluid that's in your bottle. Those are different attributes of the same noun, the same object. And each one can be distinct and unique, which is interesting. So when we write things in code, we want to think about how we can build things as objects. So when we're trying to define a problem and say, hey, I need to write a piece of software that does X, Y, and Z, anything that's a noun could be an object. Doesn't mean it has to be, but it could be. So if we wanted to write some code that managed a bank account for us, right? Things about bank accounts. So your bank account probably knows who owns it, right? And it probably knows how much money is in it, right? Are there other things bank accounts know?
Current interest rate of the institution.
So like withdrawing from a bank account, that's more an action, something you do with the bank account, right? Like you would take money out or put money in. I don't know. It might have like a list of withdrawals or like the ledger or the transactions maybe. I think withdrawal itself more of an action. And we'll get to that in just a second. Yeah, you might know an interest rate. Your checking account probably has a 0 interest rate, and your savings account probably has a really embarrassingly low interest rate, and you're losing money to inflation. I said that out loud, and my daughter cried. She takes things very literally, and she's like, "Why am I losing money in the bank? I thought you're supposed to put money in the bank." I'm like, well, no, honey. You're not losing money. You're losing purchasing power, and that didn't go over any better. Not that it made any sense to her, but it's like, you can buy a loaf of bread today for $1.50. Next year, it's going to cost $1.85 because of inflation. She's like, okay, that's all right. She's only 13, probably not quite ready for economics, but that's okay. But interest rate, yeah. So there are attributes, and each bank account can be different. Some online bank accounts will offer more better. My goodness, I'm terrible. Would offer better interest rates because they don't have the overhead fees of having to have physical locations and paying for all this sort of stuff for that. So they can offer better interest rates. Sure, they can offer that. And then things that you do with the account, ways that you interact with the object, those become methods. So the methods are the verbs of the things that the objects do. So I can drink from a bottle, right? I can put a chair up and down, or if it's a lazy boy chair, like extend the footrest in it or lean it back. Those are all objects, ways that you interact with that noun. So the ways that you interact with it, the things that it does, become potential methods. So with the bank account, we would want to be able to withdraw from our account and deposit to our account, right? You're going to be able to put money in and take money out. It's not a whole lot of other things you do with your account, right? It's pretty basic. But we could write a class that the technical term here is encapsulation. It's one of our technical terms. So we encapsulate all those details, pull them all together, and put them into one nice little package called bank account, into one class. That becomes the blueprint. And then what we can do is you can have multiple bank accounts. I don't need to reinvent the wheel and start it over again. I can say, hey, this is Eric's savings account. This is Eric's checking account. This is Eric's I don't know what other account here. This is Eric's vacation fund account. This is Eric's yada yada. As many accounts as I want to create, I just make a new instance of that class. And we've kind of been doing this before without really realizing too much about it. So scanner is a class. This new keyword makes a new instance of it and loads it in memory so we can go and use it. This particular scanner happens to know it's using the standard system input, so we can get stuff off the keyboard input. Later, when we talk about files, we'll learn, hey, scanner can also read files. If you give it a file instead of the standard input, it will happily give you data out of a file to read. The class itself just does stuff. In this case, this one knows its system input. Later on, this one will know about files. We're just calling it keyboard here. Other ones we've been using, I don't think we had a whole lot in here, right? Random is a class that we created an instance of. Next int is a method. It's a way that you interact with this instance of random. It gives you a next integer, right? One of the reasons random is nice is that you can control the seed value, right? Because it's pseudo-random, it's not actually random. You can give it a number here, and then you'll get the exact same sequence of pseudo-random numbers back out every time. So generally, we don't want to do that, because we want it to look like it's actually random and we want to have this be different every time. But if I give it like 50 here, just some number, it says, hey, this is the seed value, and we play, let's write down the computer's throws here. So we're going to do rock, and then the computer picked paper. So we're going to write down paper. Paper was their first throw. Okay, let's play again. And then let's do rock again, and then they played scissors, we win. Let's do scissors. And let's do one more here. Let's play again. I'll do rock again. And they picked paper. We lost. So they were paper, scissors, paper. I'm going to run my program again. Because I gave it the same seed value, it's going to get the exact same sequence of random numbers every time. So if we know it's going to get what paper was a 2, it's going to generate a 2. So we want to generate scissors. We want to be scissors to win. Uh-oh, it broke. Oh, I'm using the wrong one here. I'm sorry. I'm using the math random. Sorry. This one here, number 1 to 3. 1 sec. Equals that. There we go. Okay, now this will probably work here. Sorry. Math random doesn't let you set the seed. There's other ways to do it, but it's not as easy. So we'll set the seed here. All right, let's do rock. All right, so I picked paper. That's funny. Pick paper. All right, try again. Let's do rock. It picked paper again. All right, so paper, paper. One more time. Rock. It picked paper again. If we set the seed to 50 every time we ask for the computer's throw, the first time we generate a next int, we're going to get the same thing. It's going to be paper every single time. It's not actually random anymore, right? Because it's using the same seed value. And the first time you ask for a random number, you get the exact same one. So not actually useful here, but now we can win every time if we want to cheat. But if you don't give it the seed value, right, it uses that system clock behind the scenes, whatever the clock time was. So it looks like it's random because you're probably not going to start your program at the exact same millisecond. Just, time moves forward. So we can't do that. Now it should just work, right? Rock, play again, rock. Right? And now they're changing their values here. So what random is a class here. It has some attributes. The seed value is one of those attributes. And then we can use next int here. It's a method. It's a way to interact with it to get the next random number. So if we want to write our own class, let me start up a new file here. New project. This is, what week are we in? This 7? 6? 6. Week 6. Oh my goodness. Week 6. Week 6 classes. Now, Java is rather particular. I think you probably noticed here that we talked about the name of the class has to match the name of the Java file. Right? So if you rename this one here, it gets really upset with you and starts yelling. So to make a new class here, we need to add a new Java file. So we're going to come back to our package or our project over here on the left, come to the source folder, and we're going to right click and say, hey, I want a new Java class. We'll call this one bank account. Classes should start with an uppercase letter and then do the other casing as well. Every next word gets an uppercase letter. That's our convention in Java land. So now I have public class bank account in a file named bankaccount.java. If they don't match, it's going to be real upset with you. Okay. It'll warn you and tell you and say, hey, they don't match. So if I were to change this or change the casing in account, the red line here is going to tell me class bank account is public, should be declared in the file name bankaccount.java. Right? You can go rename the file. That's a nice quick option here, or depending which one was incorrect here, we can go fix it. not too bad to fix. Okay, so code is going to look a little different here. So when we started doing methods, right, with our rock, paper, scissors, we put stuff inside of the class. Same thing works here. So as we add methods, it'll be inside the class here. But for declaring those attributes, right, things that are attributes of bank account, like who owns it and how much money is in it, those are important things, and maybe the interest rate. That's probably a good one too. Those aren't declared in methods. They're declared what we call at this class level. So they're class level attributes or instance attributes. So each bank account will have its own unique set of these values here. So we're going to say, hey, I want a string for, I don't know, owner's name. And then you just say semicolon. We don't give it any values here. We just say, I will have an attribute named owner's name. Go for it. And then probably have a double here for balance. And probably a double for interest rate. Interest rate. Okay, so we have some values. We get owner's name, balance, and interest rate. So these are going to be unique to each instance of bank account, or instance attributes, or class level attributes. So anywhere in the class code we'll have access to these things. We'll be able to use them, and we'll see some of that. We'll write some methods here in a minute. So I've got a bank account. It has some attributes. So every time I make a new bank account in memory, these all get loaded, and we allocate space for them for us to set values to them. Now, if I come back to main, I can actually go use a bank account here. So I can say, hey, so usually we say type, like an int for balance, right, would be something. So we give it the type. Well, the type is the name of the class. So bank account is the type here. So say, hey, bank account, what do I want to call this? This is Eric's checking. We'll say equals a new bank account. So the new keyword here means we're going to load it in memory. It creates an instance. Creates an instance of bank account in memory. It tells Java, hey, go load one of these things, please. Once I have one of those, then I can say Eric's checking dot. So Eric's checking is the variable, just like keyboard was the variable, or when we used random was the variable. And then you put dot, and you get to see all the cool stuff you can do with it, all the attributes and all the methods. So I can get the balance, I can get the interest rate, and I get the owner's name. So we'll say, hey, the owner's name then is equal to Eric. And Eric's checking dot balance. Hey, let's make this up here. Let's go real big. Let's put $1 million in my checking account, right? And an interest rate, I don't know, 0.02%. I think I'm dreaming here, right? 2% interest. I don't know. I think I saw like 3.5 advertised at one of those online banks, but even that's like much less than 8% inflation. So you're still losing money. I mean, you're losing purchasing power. Forgive me. Bless you.
Are those underscores or commas?
And the balance,
yeah.
Those are underscores. So that's the digits separator. And they're totally optional, but it makes it easier to read numbers.
No, I appreciate that. Yep. Thank you.
So cool. So I can get some values out, and then I can make another bank account. I can have bank account Eric's savings equals a new bank account, and then we'll say Eric's savings dot, and I can set the interest rate. I can set the owner's name. Owner's name is Eric. Eric's savings. I keep typing too fast here. The balance here. Let's say this one, maybe just $500 in savings. We'll keep it all in the checking because of that sweet interest rate, right? Savings interest rate is, I don't know, let's go like 4% on the savings account. Doesn't really matter. We're just making up numbers here. But what we get to do, right, we've taken all those details and we've encapsulated them into one nice little package. So now the cool thing that I can do is I can start using bank account to do stuff. Right? So you might then want to go spit out all these details or have some way to, hey, user enter all these numbers, or maybe have an account number. That's probably another thing bank account knows is its account number, but that's fine. We don't need to go add more attributes here. We can add, any way we want to get these values, we can get them, and then we can use them in our program. So sure, let's go and maybe let's print out some details here. So we'll say your or I don't know, the account owner's name is, and we can just append in here, right, my Eric's checking dot owner's name, and then we can print out the account balance is, probably put a $sign in here, right, because that's pretty. Eric's checking dot balance, and oops, my goodness, SOUT, the interest rate I don't know, interest rate is, and then, you know, we could probably leave it as a decimal. You could change it, multiply by 100, put the percent sign on. Anything you wanted to do to make this look pretty is fine here. Not too concerned with the output formatting at this point. We're just looking at classes now. Okay, and that's all fine. And then we can do it again, right? And do Eric Savings instead. Eric Savings, sure. Now I basically have the same code twice. I'm going to feel bad about myself. So we'll look at fixing that in just a minute. Let's make sure it runs, right? Let's go ahead and run. Should see, look, Eric has $1 million in the checking account and $500 in the savings account. Awesome. It's working okay so far. But I basically have the same code twice. The only thing that's different is a variable. And I know you remember from last week with methods, if the only thing that's different is a variable, you could turn it into a method, right? We can reduce repeated code. So let's make a method out of it. So outside of the main method here, right, we're going to come in main here, and we'll make a new function. So this will be public static void, I don't know, print account details, or print bank account details. Now, what do you need to give print bank account details for it to be able to print bank account details? What's the type? I'm not going to give it a string, an int, or a string, a double, and a double. That's annoying. I can give it a nice little package, a nice bank account. So I'll say, hey, you give me a bank account, I'm just going to call it account. So we can use this new class, this new type here, as an argument or as a parameter when I define a method. This method can accept a bank account and go and get all these values out and do the things it does. So we'll take all this here, cut it out, put it in here, and I'm just going to change this to account. And then to print my bank account details, I just have to call it with Eric's checking and print bank account details with Eric's savings. So you can take that nice little package, you can take that entire class and hand it to a method for it to do all the things the method wants to do. And it has access to all the attributes, right? Here's my owner's name, here's my balance, here's my interest rate. We can go get all those out. So now I don't have to have the same code twice. And we get all the same output here. Oh, why do we have a hello world? Oops, should have got rid of that. Now again, this is not very interesting because we just put all these details in. We didn't ask the user for anything, or we haven't done anything interesting with it yet, but this is the start. So bank account becomes the package here. We've encapsulated all the details here. Now we're going to do some more fun stuff, right? It's kind of annoying to have to set all these values one at a time like this, right? Kind of annoying. So there's a special method we can write inside of classes. It's called a constructor. So the constructors, I can't spell. Constructor is a special method made to create the object. So a constructor has a different rule. So there is no return type specified. And when we're dealing with classes, we ditch the word static. So static means more things. We'll talk about that in a little while, what static means. But when we write our methods in main, right, everything is public static, the return type, the name of the method. We're going to get rid of static because we don't want to use static now when we're talking about classes. So this will be public bank account. That's it. So we don't have a return type, and there's no static keyword. So it's a public method. The name of it matches the name of the class. The name of the method matches the name of the class. This is the constructor method. So this is what gets called when you say you want a new bank account. This is actually calling a constructor method here. Calls constructor. Constructor method. Constructor? Constructor. That's a fun word to say. All right. So this here, when you say new bank account, calls that constructor. So right away it says, hey, went to two usages because we're using it right here and we're using it right here. The constructor's job of a constructor can't, oh my goodness, this is embarrassing. Constructor is to give attributes values. So you want to give it default values here. So we can say, hey, owner's name is blank. I don't know what the owner's name is. The balance is probably 0, and the interest rate is probably 0. I'm going to give values to all my attributes. Now, types that are primitives, like doubles and ints and floats and chars and things, they all default to 0. That's fine. Anything that's a class here, like a string, defaults to null. And null is really bad. Null will make your program crash because it's ugly. Null means it doesn't exist. So by setting it here to an empty string means owner's name has a value. It just happens to be empty. Before it was null, and null is no good. So let's pause on this for 1 second here. So let me go comment that out. Code comment. There we go. So before we did that, when I make a bank account, I can go and set all the values here. Well, let me do one more here. So let's do let's say bank account Eric's what is this Disney fund equals new bank account, and I try and print my account details on Eric's Disney fund. Here, let's see what we get. Owner's name is null. It doesn't crash yet, but means there is no value. It's not set to anything. So if you were to do something like try and use it here, we could say, hey, if my Eric's Disney fund dot owner's name dot equals Eric, and then we can print out, I don't know, say this is Eric's Disney fund. Right, and we run this when account owner's name is null, it's going to crash on us. We get a null pointer exception. This is the bane of programmers' existence. We hate these things with a passion. It means you tried to use something and it doesn't exist. So owner's name doesn't exist. It's null. You can't use any methods when it doesn't exist. It's not there. There is no string there. It doesn't point to anything. There's null. So you can't say null equals ignore case because it will just crash on you. It's no good. So nulls are awful. So that's why a constructor's job is to set values for those things here. So we don't have nulls. So now owner's name will be blank. Blank is not null. Blank is a valid value here for string, and I can compare. Does blank equal Eric? And it will give me back a result, yes or no. Here, it's not going to crash on me. So now we just get it's blank here, and I don't get my this is Eric's Disney fund account, which is sad. Maybe I need to start saving for Disney again. Like you have to start saving for Disney before you even go to Disney the first time. It's just nuts, especially when you take 7 kids. So it was a lot of fun though. It was a good trip. All right.
Could you please scroll up where you create the print bank account details method real quick?
That's down here. Yep.
Oh, sorry.
So you give it an instance of bank account, and we're just going to call it account inside of our method here.
Thank you.
You can call it anything you want here. Let's just print out all the details. Yep. So the constructor's job is to give values. Now, this is a method just like any other method. So if we want here, we can specify arguments or parameters. We can say, hey, when you make a bank account, why don't you tell me some details? So a pretty common approach here is we can make another method here, a public bank account. And in this version, we can give it some attributes. So I can say, hey, string, I need the owner's name. Owner's name, I need a double for balance. I need a double for interest rate. Man, sorry, just 1 second. Oh, my wife is calling. She knows I'm in class. I'm just making sure it's okay. So I can say, hey, when you want to call this method here, you can give me a string for owner's name, a double for balance, and a double for interest rate, and I'll just go take those. Now, the problem is, if I say owner's name here, owner's name equals owner's name. Notice they're both gray. And if I hover over it, it says owner's name assigned to owner's name is never used. Okay, that one's fine. But this one over here, variable owner's name is assigned to itself. Notice this owner's name is purple, and up here it's purple. So it's just a visual cue. These purple variables here are the class level, the instance variables here. This white one over here, the gray one, is the argument. I've named them the same thing. So to differentiate between the two, we have a special keyword. We say this dot. So this dot means this current instance's value, owner's name, is different than the white owner's name here passed as an argument. So this owner's name is this one here, and owner's name is this one up here. Some people think this is a bad habit. I love this because you want your variable names to be nice and descriptive, and I'll show you in just a second why that's important. So some people will say, hey, let me make that an O and a B and an I here. I can say, and I can get rid of this word here. I say owner's name equals O, balance equals B, and interest rate equals I. Now this is awful because if you want to go use those values later now, so let me go make my bank account here. Let's do my Disney fund. We'll say, hey, the owner's name is Eric, and my balance is, let's put 1,000 in there, and the interest rate's 1%. You see these little like useful little pop-ups here that tell you what the variable is? It says O, B, and I. The variables pull through, and you can see them in your tool. I have no idea what an O is. I have no idea what a B is. I have no idea what an I is. It's not helpful. It's not useful at all. So having I think now it's gone. All right, what's this? Do 702. Yeah, okay, I think we're back. That's weird. Black my whip. Load's okay here. I need it to show the other station up here. Usually I keep chat open on the other screen. But it looks like it's going steady. I haven't had an interruption here. I wonder if like the campus internet's having trouble.
Will we be able to see the screen
Oh, it loaded now.
when
Of
we
course.
revisit?
Will we
So
rewatch the video?
this part here would probably break up because the stream was unstable. As long as the stream is stable, it's making it out to Twitch, best I can tell.
Okay.
So it should be fine. Okay. Is it okay, Torchbat? Torchbat. I like that name. That's fun. I was watching someone play God of War. It looks like a fun game. Is that Ragnarok, I think?
Mhm.
Is that the one? Okay. Looks fun.
I like the Valheim.
Oh, I haven't heard that like made the news real big, and then I kind of like petered out. Is it still pretty?
I like it.
Got a lot of people playing, or okay?
Thor's still pretty active.
Oh,
That's the like crafting adventure,
Yep.
like okay,
Norse kind of thing.
yeah.
Yep.
So there used to be a game years ago
we
that I played,
determined
and
we should-
when you died, you lost your corpse, and you had to go back and find it wherever it was, and you get all your gear. And everyone said like that was mean and rough, and I can get that, and it sucks sometimes, but it adds. I don't know. I feel like it added to the game. When that stopped happening, you're like, oh, I died, no big deal. Like it made it meaningful. I felt like because Valheim was like that, right? You died, you lost all your stuff on the corpse, and you had to go to the corpse run, or like recruit somebody to come help you with it. Like, help me find my body. Okay, Starfield. Oh, that's the new. Yeah, I think I heard about that one. Very cool. Lots of good games out there.
Another dad joke.
Yeah, well, new Bethesda game.
I had a hankering to play 007 GoldenEye last night, but then I had to dig out my N64, and it just wasn't worth it.
I couldn't. I did it like 2 or 3 years ago in the game lab over at Dearborn. Someone brought in their N64s. Like, hey, let's play some classic games. I used to be really good at it. I literally couldn't walk around and look at the same time. Like, I don't know. I used to be really good at that game. The Perfect Dark I was better at with the Farsight gun.
Oh,
I could shoot people through walls, no problem.
Yeah.
Like, now I can't even walk and aim at the same time. But mouse and keyboard's much better. Okay, so I think we're stable. I think we're pretty good here. Sorry about that trouble. Should just be that one little blip in the recording there. So hopefully we didn't miss too much. We're talking about classes. The constructor here, right? Its job is to give values to your attributes. This is the default constructor. Great. Now before, when we had this commented out, here, control / right? Everything was fine and it would work, but we got that null error and it crashed and we were sad. But now I commented out and it says bank account string double and bank account cannot be applied to parenthesis. You gave it nothing, it wants a string double. Well, what happened? It worked before. So once you specify a constructor, Java doesn't give you a default constructor anymore. If I comment this one out, comment, now the default constructor is back. So anytime you write a class, Java will give you a default constructor automatically. But what you get here is primitive types are 0 and reference types are null. We said that's really bad. We don't want that. You want to have a constructor. It's the constructor's job to give default values. Even if it's zeros here, you should have the constructor do it because that's its job, right? So let me uncomment. There we go. And this one. So if you want a default constructor, write a default constructor. If you want to have I like to call it a parameterized constructor, a constructor with parameters. Parameterized, I don't know. It sounds like a fancy word here. You can go do that. So this gives multiple options for people using your class here to do something with it. Now, for our case, we're the person using our class from here on out, this entire semester. But later on, when you know more and have practiced more in these sorts of things, you can write classes that other people will use. And when you work in large groups and big organizations that write large pieces of software, one person isn't going to write the whole thing. Right? You're going to take the work and you're going to break it up. This is another reason classes are awesome. You can break things up class by class by class by class and say, okay, here's a noun, here's a noun, here's a noun, here's a noun, here's the way these things interact, right? We can kind of put all these pieces together here, and each person can do their own part here, and then we'll assemble it all together at the end. So we're the one using it here. No big deal. We know how it's going to be used, but later on, our classes, we're going to write such amazing code, other people are going to want to use it. So we want to make sure that we do the right things with it, we take care of it. Now, stuff just like accepting a balance or accepting an interest rate, it's a little risky at this point. So we've taken all the details here of bank account, encapsulated into one nice little package, but we aren't really protecting the integrity of this class. Right? This class's job is to manage a bank account here. Now, interest rates probably have some sort of range, right? We're not going to give someone 100% interest because we're not a Ponzi scheme. That just doesn't work like that. So if we want to put guards around values for things here, we can do that with our class, which is really cool. So we're going to look at how we can add more functionality to this so that a bank account can maintain its integrity. It can follow its own rules or constraints. So this idea, when we're solving a problem, things in the real world have constraints or business rules or logic around what makes sense for them. So when you talk about a bottle and you have volume of your bottle, like how much liquid can go in here, it can't be negative because we need to obey the laws of physics, right? It can be 0, I mean, close to 0. I don't think you can actually get absolute 0 vacuum in this bottle, but we could try, right? Sure. So we can add some constraints around that and say, when you make a bottle or when you make a bank account, here's the valid range of values. And if you give me something invalid, I just won't accept it. So we can check for that. So we can say, hey, when you give me an interest rate, let's see. If the interest rate is less than 0, well, you probably aren't going to pay the bank money here to have an account there, right? There's no negative interest rates are probably a bad thing, right? So we just won't take it. So we'll say my this interest rate is 0, right? Else if the interest rate is greater than 1, probably don't want that either, right? Because they probably gave me the wrong number, right? Maybe they were thinking the rate is like the number 6 instead of 6%, 0.06. Well, sure, maybe I'll set my this interest rate to the interest rate divided by 100. Just assume you did a bad thing. Again, we can add some other checking here, but whatever sort of logic we want to come up with here is completely up to us. Say, hey, if you give me something greater than 1, or maybe even greater than or equal to 1, right? Because 1 would be 1%, right? That's probably fine. Sure, so if it's less than 0, if it's greater than 1, we'll do that. Otherwise, else here, my this interest rate equals interest rate. So if it's not less than 0 and it's not more than 1, it's probably between 0 and 1. That's probably a valid interest rate. Now, maybe you said 99%. Sure, that's up to you. You know, I don't want to be that specific around what my rules are, but it can't be more than 100%, and it can't be less than 0. So we can add constraints here around those values. Constraints or protections from invalid values, right? We get to set the rules. Now, the problem is someone can just come in here and set what the interest rate is, right? I went through all this trouble to say, here's how you set a valid interest rate, and now someone can just go change it. And we don't want that to happen. So we're going to add a new keyword here. So notice all of our other methods have been public here. Public this, public that. There's another keyword. If you don't want someone to have access to it, you say this is private. We're going to add a private keyword to all of these. Say these are private values. Private restricts access to the value to just the class code. So the only place they can access the code is inside the set of curly braces now, because we've marked the value as private. So no one else can go and set that value here other than us inside the bank account class. So now over here, I can't go set all these values. When you say, well, how are we going to set them? Well, what we need to do is we need to give them public methods to interact with. So we're going to write public methods. Now, the common approach for these is you write two types of methods. You write get methods or accessor methods to access the value or get the value, and you write set methods or mutator methods to change or mutate the value, set the value. And it seems like a lot of work, and it's a little bit of typing here, but I'll show you a shortcut after we do it the hard way first. So we'll say a public method, right? And then all of the get methods are going to return values. So public string get owner's name doesn't need any arguments. We're going to return owner's name. That's all it does. It's a very short method here, but it gives a public access to getting what the value is, right? Because I don't have access to it directly. I said, hey, this value is private because I don't want people changing it on me, right? Because who knows what people are going to do. So I want to control that access here. So there's the get owner's name, and they'll have a public void set owner's name that needs a string for owner's name. And I can say this owner's name is the owner's name. So now I have a public method for getting the value and a public method for setting the value. So if you want to tell me what the owner's name is or change the owner's name, you call my public method, right? You don't access the value directly. We're encapsulating those details and hiding them away so you can't change them and do bad things with them because we don't trust people. I mean, for owner's name, it doesn't really matter, but like for balance, we probably want to put rules around balance, that sort of thing, rules around interest rate. Sure, we can do all of that. So now instead of saying owner's name equals Eric, I'd say Eric's checking dot set owner's name, and in parentheses I'd give it Eric, right? Because this is now an argument to the method set owner's name. So I have a public method that I have access to instead of accessing that variable directly. So this is the best practice here. You make your values private. It's bad practice to make them public because then just anyone can go and change them on their own. So we don't usually do that. We start with that because it works, but it's bad. And I don't know, you'll see it, but we try not to do that. So this is the hard way of doing these things, right? Set and get, you write them yourself. So it turns out this is very formulaic, very convention based, right? It's get variable name, set variable name. So us programmers who are lazy said, wouldn't it be nice if the tool would do this for me? Yeah, it does. So you right click here and you say you want to generate. What do you want to generate? You want to generate getters and setters. Well, what do you want to generate them for? Balance and interest rate. So you can click or shift click to highlight multiple. If you just click one, you only get one at a time, but you can like shift click or control click multiples. I want them for both. We'll say okay. And now here's a get balance method. Here's a set balance method. Here's a get interest rate. Here's a set interest rate. Now, it doesn't do any of that checking yet, but I have the method. Now I can go and add all this other stuff. So if I have all of this here, right, I don't want to have the same code twice, right? Because then I should feel bad about myself. So I'm going to move this all into set interest rate here, and then up in my constructor, right? So this is, I'm going to move my comment down here too. We can just call that method. We can say, hey, I want to set interest rate given the interest rate, right? I already have all the logic around what is a valid interest rate here. I don't want to have it twice. And so you don't have to. Put it in your set method, and then just use that set method. Right? For balance, we can put rules around balance, right? Probably, hey, if my balance is less than 0, we're going to just say balance equals 0. Otherwise, we'll just take the balance, right? Oh, sorry, this dot balance. So it wasn't the purple one, right? So that was bad. So if you want to tell the bank, hey, this is my balance in my account, the bank will take a positive number. But if you tell it, hey, bank, I have negative $100, we're going to assume that's invalid here, because you probably, technically you can, because banks are awful and let you do that sort of thing, and then charge you more money when you don't have enough money to pay for the thing that you should have just not been able to pay for. They're like, oh, sure, we'll pay for that for you, and then you owe us $35 more for overdrafting. And you're like, well, I didn't have enough money to buy this. How am I going to pay your overdraft fee? Because that's just stupid. I don't know. Banks used to make money lending money, and now banks make money charging their customers fees instead of lending the money out like they're supposed to. So it's another whole thing. Sure. So other things we have to change then, right? It's not balance now, it's set balance. And we give it this value in parentheses because we're calling the set balance method. Same with interest rate. It's not dot interest rate, it's dot set interest rate given 0.02. So we can call all these set methods. So we want set owner's name, parentheses, set balance, parentheses, set interest rate, and parentheses. Okay. With the Disney fund, we don't have to do that, right? Because we used the constructor that gave all the values already. So again, totally optional. However you want to make these things work. You can have the constructor, or you don't have to have the constructor, and people can go set their own values here. Both work. But now it's not dot owner's name, it's dot get owner's name. Dot equals ignore case Eric. Right? So we can check, hey, the Disney fund get owner's name will give me back this string. You can, if it's a string, you can use the dot equals ignore case on to see if it matches another string. So you start to get this chain of dot, 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 dot. You can make these things as long as you want to get, right? It can get a little crazy, but the Disney fund is a bank account. Bank account has a method called get owner's name that gives you back a string. A string, then you can use dot equals ignore case on, check it against another string, right? We just kind of follow these from left to right. And then these ones have to change, right? This is get owner's name and get balance and get interest rate. Right. So now it should run. It's going to look identical here, but now our bank account code is making sure we don't give it invalid values for interest rate and no negative values for balance. Right? We don't let that happen. So these are just get and set methods. They're not really interesting yet. So really all we now have is a way to hold all these attributes together, a way to get those attributes and to change those attributes. Now we want to add, how do I interact with my bank account? Well, I want to withdraw money from a bank account. I want to be able to deposit money to a bank account, right? So we're going to add more methods now that let us interact with it here. So we want a public void deposit given a double for amount to deposit, right? So if you want to deposit some money, you tell me how much you want to deposit. I'm going to take my balance plus equals the amount to deposit. Now we probably also want to do some sanity checking here though, because I don't know what people are going to give me here for an amount to deposit. I want to make sure it's positive. So I'm going to say, hey, if the amount to deposit is greater than 0, then we'll go do this thing here. Right? That's it. If it's not greater than 0, I just don't do it. Right? It's totally up to me. This is my code for my bank account here. So if you try and give me a negative amount, I just do nothing. I ignore you. Go away. You can't deposit a negative number. Right? There's other better things we can do. We just aren't going to talk about them until, when are we going to talk about those? This one. Once we get to here, we'll learn some better ways to deal with this. But that's fine. We just, there's little pieces at a time. Okay. What you don't want to do here is you don't want to print a message. A class should almost never have system out print lines. Because one of the ideas with writing classes here in object-oriented programming is that the class has no business knowing where input and output is coming from. Right? Ideally, this class is so fantastic and so wonderful that someone wants to use it in a graphical user interface program. Do you guys ever see console output when you use a graphical user interface program? No. So if your class is spitting something out in the console, no one's going to see it. If they use your class here in a web application, go take our web systems development class that I teach. We'll use Java to write web applications. No one will see your console output because it's a web application. They only see the stuff you put on the website, right? So classes shouldn't be dealing with input and output unless that class specifically is meant for dealing with input and output. So we never use system out print line. So you don't say, invalid deposit, right? In an else here, right? So this is no good here. Please don't ever do this.
Can you repeat again why you don't ever do that?
Don't. So classes have no business with input and output, with like console input and console output. Classes shouldn't rely on console input or output. If you want to give the class a value, it's an argument in a method or a parameter. If you want it to give you back a value, it's a return. You're going to return something here. Because that way you can take this class code and I can use it in a console application if I want people to type in the console. I can use it in the graphical user interface application. If people want to use a graphical user interface application, I can use it in the web application. I can use it in the mobile application. Java works on all of them, which is really cool. Right? Go take the mobile development class with Dr. Baugh. Or actually, Mr. Nasser's teaching it sometimes too. But anyway, you want your class to be independent of where it's running. Right? So if it's a mobile application, there is no console output. Okay, I think I said that a lot. I'll say it every time. People do this all the time and it drives me crazy. It's okay. That's the only thing you know, and the only thing we've done is console applications where there's text on the screen. But I promise you it gets much better. It gets much more interesting, and we'll get there to the interesting stuff eventually. You'll learn all of it in the program here if you are doing software engineering, which is fun, right? We like graphical programs, we like web applications, and we like mobile applications. All of you have a phone, right? You use mobile apps. They're fun. Sometimes they're fun. Okay. You're going to ban the word console application in real life. Okay. Ancient bags. I'm not allowed to say those words. How about for like 10 minutes? So it's one of the funny redeems if you're on Twitch. You can ban a word, and I'll try not to say it. Like you get a bunch of default options when you start streaming because they're like Twitch is like you should do this more often because it makes us money. Actually, I don't know if it makes them money. Sometimes it makes them money, depending on how popular you are or something. So apparently it costs a lot of money to stream network bits places. I really was kind of surprised by that, but sure. Okay. So don't do this. We don't want to do that. So our deposit, great. We can add some money. Now, the next one, which is a little bit more interesting, is the withdraw. If I want to take money out of my account. Now, withdraw is either successful or unsuccessful, right? Because if you don't have enough money, I'm not going to give you the money if I'm the bank, right? So we're going to return a yes or no value. Remember there's a type we talked about a while back that's a yes or no, a true or false, an on or off. It's a Boolean. So this would be a public Boolean withdraw, given a double amount to withdraw. Now this one is going to give you back a yes or no, a true or false, whether or not it was successful here. So we don't need to spit anything out on the screen because I will tell you true if it was successful. I will tell you false if it was unsuccessful. You can say, hey, if the amount to withdraw is greater than the balance, we're going to return false. Lowercase f false. This is no good. Did not work. Right? I give you back false. Invalid. The ATM to eat your card. Probably doesn't actually eat your card, right? Oh, I hope it doesn't. Otherwise, though, if it was not greater than our balance, we'll take our balance minus equals the amount to withdraw, right? Take that out of our balance, and then we'll return true. Say, sure, you withdrew the money successfully. Great. So this one, right, is giving you back this Boolean result. You could do the same thing with deposit with a true or false and give them back false if it didn't work. Sure, I mean, that's an option. Any way we want to do it, it's fine here. So this is however we want to write our code will work for us here. Okay. So now I can go and interact with it here. So again, not super interesting here, but why don't we we'll print our details and then we'll set up a scanner. Scanner keyboard equals a new scanner. And then system.in. It says I don't know what a scanner is. Yeah, we'll go add the import. as our import line. That was Alt-Enter to do that light bulb thing. And here we'll ask them, right? So we'll say, hey, I need to, much money you want to withdraw. Is it withdraw? Withdrawal? I think it's just withdraw, right? Withdrawal is the verb? I don't know. Bad at English. And we'll make a double for amount. Here is keyboard.nextLine, but because that's a string, we need to convert, right? So double dot parse double. Given the keyboard next line, oh goodness, given the keyboard next line, there we go. Too many letters. Okay, and then I'll take Eric's checking dot withdraw the amount. And in here, right, because withdraw will give me a true or false, will give me a Boolean, I can say, hey, if Eric's checking dot withdraw, and then we can say withdraw successful. Oops, so it's missing a parenthesis. If it was not, right, if it was not true, we'd say unable to withdraw that amount. And we can even tell them, right, your balance is maybe. Your balance is Eric's checking dot get balance. And we'll give them a message, that sort of thing. If you want to go crazy here, we could put that in a loop, right? If they want to withdraw, we could put all this in a loop here and say, while here, Eric's checking dot withdraw amount, and then all of this would, I want, if that's not successful, I want the loop to run, so I would say not withdraw. Because if I get back a false, not false becomes true, my loop runs again. And then we can put this here and change all that up. Oops. And let me tab it in. And if it didn't work, then, right, ask them again. So ask them how they want to withdraw. If I get back false, I say not false, the while condition is true, the loop will run, and tell them you can't do it, try again. If it comes back true, I say not true is false, the loop doesn't run, we just tell them it was successful, right? Eventually this loop ends and we tell them you're successful. So this was my checking account. We probably should have done a different one, but that's fine. So how much do you want to withdraw? This one has like 1 million in it, so we got to do a really big number, right? So it's unable to withdraw that amount. Your balance is, yeah. How much do you want to withdraw? Let's withdraw like 1,000. Successful. There you go. And you know, do you want a receipt? Do you want to show your balance on the receipt? All those things the ATM usually asks you. We could do all those sorts of other things here if we wanted, right? We could probably even ask them which account they wanted to withdraw from, right? We should do that, right? So we should ask them. So let's say which account you want to withdraw from. And then I happen to know it's checking, savings, and Disney Fund, right? If we didn't know that, we'd have to go through and do some other stuff. We don't really have a good way to do that right now, so that's okay. So we'll just tell them, I'll just say from here. And then we'll get a string for account is going to be keyboard.nextLine. Now, I don't want to have the same code more than once, right? Yeah, you don't want that. So let's take all of this and put it in a method. So public, remember we're in the main section here. So all the methods here are public static. Void draw from account. And here, to withdraw from an account, you need to tell me which account. So now instead of it being Eric's checking, it's just the account. And then it needs another scanner. Let's go grab that one here. I think we had that right here. Sure. So how much money you want to withdraw? Get the amount. Try and withdraw from the account. If it didn't work, didn't work. Withdraw successful. We should tell them what the new balance is. Our new balance is account.get balance. Sure. Right. So then we can say, okay, if my account.equals ignore case checking, then we'll take my withdraw from account given Eric's checking, right? So else if my account equals ignore case savings, right? We'll call the withdraw from account method giving it Eric's savings. Else if my account dot get account dot equals ignore case was it the Disney Fund? Disney Fund, sure. We'll call withdraw from account withdraw from account given Eric's Disney fund. Else, I don't know, we'll just tell them you didn't recognize that account. Didn't recognize the account. Recognize. There we go. Right, so we can just go through and check. If it's this one, this one, this one, right? Do the exact same code, but use this account. Do the exact same code, but use this account. Because we can use classes as arguments here, the same logic happens no matter which account it is. Let's give it a try. So which one do we want to try and withdraw from? We've got $1,000 in Disney. We've got $1 million in checking and $500 in savings. Savings, okay? How much money do we want to withdraw? We should be able to do, if we do more than 500, right? Let's try and get 1,000 out. It says unable withdrawal. Your balance is 500. Right? We're back in that loop. It's telling us it didn't work. We do $100. Withdrawal successful. New balance is 400. Program ends. Or like, hey, do you want another transaction? Whatever our ATM thing does, right? We can add in a thing where you have to enter your PIN and do all sorts of fun stuff. So maybe your account knows your PIN. I don't know. We got lots of options here. We can do some fun stuff. You with me so far? So is a lot. It's a very different way of thinking. We're kind of very far departure from, top to bottom. Hey, now I can add some loops. Now I can add some methods to repeat some code. Classes is a different way of thinking. It's a different way of solving problems. But the reason why they're useful is because we understand classes as people, right? If I tell you a tree, you probably aren't thinking about the oak tree in my front yard that still has leaves on it in the middle of winter, which confuses me. I don't know why that thing never dropped its leaves. They're all brown and gross looking. But, right, that's a tree. You know other types of trees. The same idea goes with our code. We can make other instances of this class here, and they each get their own unique values. So you don't technically need classes. There are programming languages that don't have classes at all. So it doesn't give us new functionality, but it gives us a different way to solve problems and a different way to approach them and a different way to work with things. And I like to imagine it's faster and shorter to say, hey, I will hand a method a bank account, and it can go do all the things bank account does. Right? If we didn't have classes, I would have to have a group of variables like Eric's Disney Fund owner's name, Eric's Disney Fund balance, Eric's Disney Fund set interest rate, and then Eric's checking balance, Eric's checking interest rate, and have all sorts of different values that I was tracking for each one of these things. It feels really annoying. Yeah.
I have a quick stupid question.
No stupid questions. Don't say that. Sorry.
So I understand what you're doing from where you came, but my question is, does IntelliJ track those changes?
What kind of changes?
Like how you eventually started changing each of the details, like account name, Eric's account checking account to this account, or do you know what I'm saying, or no?
So
as you've been adding and changing and putting the new methods in,
yep.
You've had to swap things around or change it.
Yep.
Is that trackable in IntelliJ or no?
So not so much. So like when I made a new method here for withdraw from account, I said, I want to call this thing account. And then I had to go manually change all these things that was Eric's checking from Eric's checking to account.withdraw. So whatever this variable name is here is what I'm going to call the account you give me. So you can give it the checking, the savings, the Disney fund. Inside the method is just called account. So it's just account dot. And it's any bank account you give me, it will try the method on.
Can I make a possible suggestion?
Yeah.
So how we start out in the first of the session where the variables are named one thing, right? And then usually after break we come back and swap it around a little.
Yeah.
I know personally, maybe if we committed the original
okay.
and then did like commit 1A, 1B, because personally when I'm at home and I'm looking at it, trying to figure it out, I'm like, wait, account's not here. And
okay.
I got like time marker 5 minutes.
Oh, because the code that's committed is not what you're looking at. Okay. That's doable. To go and see that in GitHub is a little trickier. You can see all the commits. So I can definitely make a commit.
I was just a suggestion.
No, that's a good, because that way you can see it evolve, which is really fun. So here's
kind of like the idea that you were having for our projects.
Yeah, where you can see the whole history of it. Yeah. So if I go change this again, then so let's do.
Sorry.
No, that's good. That's a good idea. What do we want to do here? So let's do another one of these for deposit, right? Why not? So which account do you want to deposit to? And now I can just use the same account here. It's perfectly fine. And then we'll need a method then for, we probably don't even need a method for deposit. Right? We just need an amount. maybe, okay, so let's do it without a method, and then we'll commit it, we'll do it with a method. That'll be fun. I'm sorry?
Yeah, whatever you want to put it. Go ahead and put it.
Yeah, thanks, just take your money. So make sure you get the right account number on that deposit slip. I had someone do a wire transfer. They were trying to buy a car or something, and they put the wrong number down on the wire transfer. That's a nightmare, apparently. Yeah, don't do that. So it turns out like cryptocurrency stuff too is real bad at that. You put in the wrong account number, it's gone. It's just gone. So
Always
a test transaction. Here, let me send you a penny. See if you get it.
It reminds me of that podcast where you were saying like check a penny, and then you do it once or twice, and they move it up to like $100. And if you accidentally hit accept, it's all over. Like, okay, so I'm not big on TikTok, but my boyfriend is, and he was showing me there's like this new trend where like I'll send you a penny, right, and you'll accept or deny it, right. I'll send you another penny, and then like 2 or 3 times after, I'll do a withdrawal for $100.
And so without looking, I authorize a withdrawal
Yeah.
instead of a deposit. Oh, that's annoying. Yeah. Don't authorize withdrawals. Okay. So if we're going to deposit money, right? I could say, okay, to the checking, it'd be how much do you want to deposit then, right? So we need a double. How much do you want to deposit? And then we'll get a double for deposit is double.parts double. Given keyboard next line. And then if it's checking, we can say, okay, sure, let's do my Eric's checking dot deposit, the deposit. Right? If it's savings, it'll be Eric's savings dot deposit, given the deposit. And if it's Disney fund, Disney fund dot deposit, given the deposit. Cool. So that's version 1, and we didn't recognize an account. So that should work, and we'll go give that a commit here. So deposit. Oh, definitely. So I'll show you where you can see it in just a little bit here. So let's give that a run. Maybe we should deposit before we withdraw, but that's fine. So from checking, we'll take $100 from checking. Great. New balance here. What account do you want to deposit to? How about we put it in the Disney fund? Disney fund. How much do you want to deposit? We'll put that $100 in. We took it out of checking. We'll put it in our Disney fund. Seems like it was okay here. Now, again, we don't necessarily need all of this to happen right here. That could happen somewhere else, right? So we get the account, sure, and then we'll take all this deposit stuff. I'm going to move that out. Make a public static void deposit to account, given a bank account. And this one then can go ask how much we want to deposit. Sure, we'll get set it up with the scanner. And then same idea, we just give it the account here. So then we call account.deposit. Oops, there's a semicolon there. It's like in the middle of the line here. That's weird. And we say this is now account.deposit because this is the argument for account. And this should just work, right? We're not giving back a true or false. If it's negative, just nothing happens. It just doesn't matter here. So then we can use that method here for deposit to account, given Eric's checking, deposit to account, given Eric's savings, and deposit to account, given Eric's Disney fund. Okay. Then this should still work. Okay. Which account do you want to withdraw from? So checking for 100, Disney fund for 100. Cool. And we probably should show them what the new balance was too. We forgot to do that, didn't we? We can say your new balance is account.getBalance. Okay, so we'll tell them what the new balance is. So life is pretty good here. Now we still have the same code multiple times though, right?
Mm-hmm.
We feel a little bad about that, right? We're doing this checking savings thing multiple times.
No.
Well, if the account equals checking, or the account equals savings, or the account equals Disney fund, right? We're doing the same check more than once. Can we do this differently? Yeah, we can do this one different. So let me do this one here. So this is with method commit. Commits are free, right? So if we wanted a way to get an account name and give you back an account, we could do that, right? We can write a method for that. Now the problem is though that these accounts only exist inside the main method. So if I want to use them in a method, I need to give them to that method. So the method's going to be a little ugly here, but it could work. So we'll say public static bank account is going to be the return type of, I don't know, get account by name or something. Sure. Now, to do this, you're going to have to give me the bank account. Oh, this is ugly here now, though. Bank account first, bank account second, bank account third. So you have to give me 3 bank accounts, and I give you one by name. This only works if we know we have 3 accounts. So again, until we get to our arrays and array lists, we don't have ways of making a list of things. Once we get here in a couple more chapters, we'll figure out how we can have a list of things that I can go through, but we don't have that yet, and that's okay. So you give me 3 accounts, I'll figure out which one it is by name here. So we'll ask them, hey, which account do you want? Which account do you want? And then we'll get their string for account name, string as a keyboard next lines. We need the scanner here. And then we'll check, hey, if it's checking, if it's this, if it's that. So if it's checking, we're going to return first. This is ugly, so we'll call this checking. Let's do that. Bank account checking, bank account savings, bank account Disney fund. So if you give them to me in order here, I can get them back out. So we'll return checking, also return savings, return Disney fund. Now I'm going to get rid of this if here. Oh, that's kind of ugly though, isn't it? So maybe this should be a validation loop. We can do that. We could say while count dot equals checking and or not checking, right? If it's not checking and it's not savings and it's not Disney fund. If it's not, we'll ask them again. Right? Once we get one of those valid options, then we're good. And then this can just be an else here. I can return the Disney fund. So this will be happier because if you don't have a valid option, I need an account to give you back here because it's expecting a bank account. I can't just give you nothing. Like we can't return an empty string. Returning an empty bank account is kind of weird here. So you give me the checking, the savings, and the Disney fund, and I will give you the account back by name. I'll ask you what name it is and give you the right one back. So I can use this one here then in all of these. So instead of saying deposit to account here, I don't even need to ask them here. We're going to say, oh, we don't need the didn't recognize account either. Look at that. This is awesome. So all of this can go away, and we can say deposit to account given the get account by name, given the checking, savings, and Disney fund. This is my deposit to account. Now, I guess we don't really have a prompt here, so maybe we should also give them a string value for the prompt, a string for prompt. We can spit out that prompt. So this one here then will be get account by name. Which account do you want to deposit to? This gets a little long here, so let me bump that down. Does this make sense? We're going a little crazy with our methods here, but then withdraw is the same here. We can get rid of all of this here. And this will be withdraw from account, given the account name. Which account do you want to withdraw from? Given the three accounts, the checkings, the savings, and the Disney fund. So by using methods, right, the piece that's repeated here, we don't have to ask which fund, which account it is again. We can just quickly get them back. So we have a method that returns an account. We're giving that account to the deposit or withdraw function here, right, depending on which one of those we wanted to do. So that's this version, new method for getting an account by name. All right. So if you want to see all these here, if you go to view on GitHub here, and you go look at week 6 classes, and you look at the main.java, you can go to history, and you can look at each version here. So this is classes part 1. You can see the file. Now it's going to show you everything, which is a little bit annoying here, but you can look at main. This is the main file as of this version. Or you can go back and say, hey, I want deposit part 1. This is what we added here for part 1. If you want to see the whole file, you can say, I want to view file. And we'll open up the entire file. Now, notice it says blob and a big, long, ugly thing here. that's the specific commit. So it's showing you the version of that commit, right? A commit's a snapshot. You can always get back to that snapshot once we have a commit. That's the power of GitHub. It's awesome.
Thank you.
Yeah. So like with a method here, now this looks a little funny, but it's showing red is stuff that was removed, green is stuff that was added. If you don't care about that, you can just go view the file and see the version as it was committed. Right? Whatever makes more sense for you. So you can go back and find all those. So you'll have to shout at me or holler at me to make sure I'm doing commits, but I can definitely do them as we go because that is a good idea. It's a good way to go look at that. All right. So we're going a little nuts with our methods here. Having some fun. All right, let's go back to the book, see how we're doing. So part 1, object classes and instances, right? Here's a class for something. Here's its attributes. Now, the static keyword, this is a little funny here. Static is not every instance gets its own value. Remember I said we're going to ignore static for a little while? What static means is that there is one value for the entire class that's shared. So I could make as many user data as I want here, but they all have the exact same name and age, which is probably not very useful. Why would I want more than one user data, but they all share the same value? So it's stored at the class level if it's static, not at the instance level. Not every time you make a new instance do you get these things here. So if I have class for player data and I have non-static values or instance values, right? The instance of player data gets name and age, instance of player data gets name and age, instance of player data gets name and age, but the player count is static. That one, then we could do something with, maybe it counts how many players, how many users we've added here for player data. It belongs to the class level. It's shared among all instances of the class. You do more of this in the object-oriented programming class. We tend not to use static stuff outside of that main method here. It starts to get a little funky here in some of those cases. So objects, like this is the class for students. All right, let me zoom this in here. Maybe too much. Student has 3 different tests here, and it can get an average. Sure. Right, you have attributes for 3 tests and your name, and then we'll give you back the average. Again, he starts with everything being public, which is a bad habit, and then we learn the better habits. It's a quick, easy way to think of things. You have students. So when you make students, right, instances of students, name is a string, which is another reference. It's another object. So somewhere out in memory, Mary Jones is stored and John Smith is stored. Name just knows where that's stored. It's a reference to it, knows where it lives in memory. Student 1, student 2, and student 3 know where students live in memory. Now, student 1 and student 2 happen to be the same student because he said student 2 equals student 1. It doesn't give you a copy here. I now have 2 variables pointing to the same location in memory. That's ugly, bad stuff. Again, we'll talk more about that next week too. Student is a unique student. Student 1 and 2 are here, and student 3 can be null. Anything that's a reference type, you can give null. Again, null is really bad and ugly. You don't like nulls. Nulls crash your programs. Nulls make you sad. So getters and setters, right? The practice is you write getter and setter methods, get and set methods to get your values, and then you can have private values here. That's good. Arrays, we're not going to get to until the next chapter. Don't worry too much about his arrays. Our constructors, right? Giving values to things. That's a constructor's job. So his class here, pair of dice. You have different values for dice. When you roll the dice, we'll generate new random numbers. Sure, we can do that. So that's roll. But now a constructor then can go and set the values. Either you tell me what the values are, or I can go randomly set them for you, right? We have some attributes here. So the default constructor we'll call roll, or you can give me a constructor and say, here are my values for die 1 and die 2. Right? 2 different options. Either way you want these to work, it's up to you. If that's how you want to write your code, whoever writes the code gets to define how it gets used. To roll 2 pairs, right, makes 2 pairs of dice here in memory, the first pair of dice and the second pair of dice. So we have 2 unique sets of dice in memory that we can interact with. I can roll one, I can roll the other, right? Eventually we can play Yahtzee. Do you guys ever play Yahtzee?
Yeah.
Oh, good. I gave another class of mine a project to write Yahtzee, and no one had ever played it before, and I was really confused. But I don't know. That's okay. Yeah. I mean, we used to play real games, right?
Yeah.
I don't know. Sure. So gets and sets. This idea of garbage collection. So Java is a managed language. The Java virtual machine runs the Java program and manages it. It does all sorts of cool things. So one of the things that happens in programs is when you ask Java to store something, it has to go get some location in memory. It says, hey, I will go store it in memory somewhere. When you're done with it, Java tells the computer we're done with it, and it can use that memory again. That's the garbage collecting process. for that to happen, your variable has to go out of scope or no longer be referenced. So as long as main is running here, these variables are referenced, Java knows about them, they won't get garbage collected. But if in a method here, we make like a new scanner, when this method getAccountByName is done, the memory that Java allocated, asked the operating system for to make this scanner, is going to get freed up. Java will say, hey, I don't need this thing called keyboard anymore, you can get rid of it. And the garbage collector will tell Windows that it can go use that memory again. Right? So the Java virtual machine talks to your operating system, so it does that garbage collection and frees it up. If you don't have garbage collection, you have a memory leak. You keep allocating new memory and using more memory and using more memory and using more memory. That's called a memory leak. Eventually, you eat up all the memory your system has, and it's really sad, and something crashes. It's bad stuff. C++ is terrible at that because it's not a managed runtime. It's not a managed language. If you don't explicitly free your objects, C++ just holds on to them forever, which is probably a bad thing. So Java takes care of that for us. Once we're no longer referencing it, it gets freed up automatically. It's fantastic. It's a great language. Programming with objects and built-in classes talks about we've used these things before, right? We've used classes. There's a date class, which is fun. There's an object class. Everything is an object. We'll talk more about what that means next class here. But you'll notice when we first made bank account, right? And I said Eric's savings or checking dot. There's a bunch of things here that we didn't write. Right? We wrote get balance, we wrote deposit, we wrote withdrawal, we wrote get interest rate, get owner's name, set interest, set balance, set owner's name. Those are all ours. These other things, equals, hash code, toString, get class, notify, wait. We didn't write any of these. These all come from the object class in Java. Don't worry too much about it other than that they're here. We'll talk more about it next week. Is that a question? Barely, I'm sorry. I have a hard time hearing. So set balance is the method here. Eric's savings is the variable that main knows about. So we made a variable called Eric's savings. It is a type of bank account. So then we can use methods of the bank account class here. And then set balance will work on the values stored that Eric's savings knows about, because Eric's savings has a string for owner's name, has a double for balance, it has a double for interest rate. When you say Eric's savings dot and you call these methods, it will work on that instance's values, separate from Eric's checking and separate from my Disney fund. Where I make the bank account. So like bank account, we said, hey, you have private values here for owner's name, balance, and interest rate. Because these are private values that we didn't mark as static, every instance of bank account will get a copy of these. So I can make 100 different bank accounts in memory if I wanted, each with its own name, balance, and interest rate. Right? These will be unique to each instance. So every time I use this new keyword, I say, hey, new bank account, Java will go out and allocate memory for all of my attributes here, and then my constructor runs, whether or not I call the default constructor or I call the parameterized constructor. One of these constructors will run and give values to all of my attributes. That's how we create classes and we work with them. And then when you use the methods like deposit or withdraw or gets and sets, they work on your instance's values here. So my checking account will always have the checking account balance. My savings account will always have the savings account balance because they know about their own values for these instance attributes here. Like these ones. So it's my variable is the instance of bank account, and then I call the methods that we wrote of that class. So the class is bank account. So any method we wrote in bank account is accessible through the bank account variable called Eric's checking or Eric's savings. We can call any of those methods that we wrote. So the methods belong to the class. So if you have an instance of the class, dot method, you can use those methods. Does that make a little more sense? Cool. Yeah, so Eric's checking is the variable we create in the main Java file. And then you can use, because it is a type of bank account, you can use any method in bank account when you say Eric's checking dot. Because it is a bank account, so it'll give you all those things. So we made like strings. I got a string for name. I could say name dot, and these are all things you can do with strings. Because this is my instance, this is my variable for string. these are all the methods you can do with strings. So you can say, hey, if it equals, I can take it uppercase, lowercase, those sorts of things. We can work with it here because it's a string. You get all these string methods with this dot notation. It's a funny way of writing stuff. Is that good? All right, cool. So using a class, so he'll go through, if you don't, he showed JavaFX stuff way early. We'll get to this later. You can draw funny pictures, which is cute. This won't just run if you copy paste it though. You got to do a bunch more things. So I wouldn't try and run that one. This idea of object-oriented analysis and design. How we think about our programs, how we design our programs, right? It's thinking of things as objects. So when we're talking about writing a solution, anything that's a noun could be a class. The attributes of that noun are all the instance variables. The things that you do with that noun, all of its verbs, are methods, possible methods, right? It doesn't have to be, but you can do that sort of thing here. And then he gives an example. This last one is just going through and building these things out here. So if you wanted to make this idea of how do I deal with cards in a deck and have a hand of cards, right? We got to have a class for deck, right? We don't need to actually write anything here yet. It's just kind of thinking through what it might look like, kind of designing it. Okay, well, you should be able to shuffle a deck. You should be able to find out how many cards are left in the deck. You should be able to get a card from the deck, right? For hand, you should be able to create a hand. You should be able to get rid of all your cards. You should be able to add a card to your hand. You should be able to remove a card from your hand. Sure. Either by card or by position. That's kind of annoying. Like take the fourth card out of your hand. I don't know. Why not? Find out how many cards are in your hand. Get a card in a given position. Sort by suit. If you want to sort your cards by suit, like when you hold them all in your hand, you want to kind of order them the right way, or sort by value. Sure. Just some ways you might want to interact with your hand of cards. We're just coming up with ideas here. Notice there's no finished code yet. It's just ideas. And then for card, right? Card knows what its suit is and it knows what its face is. Here. So it has a suit. It has, right, this is, sure, you can have a joker in there if you want. Why not? Value and suit. Sure. We don't get to what this throw stuff is till later. So he kind of jumps around with his examples, but that's fine. If you want to get your suit as a string, we'll know, hey, if you're spades, we'll give you the string for spades. Sure, we can do those sorts of things. We'll get your value of your card, right? Whether or not it's an ace, a 2, a 3, 4, 5, 6, 7, 8, 9, 10, jack, king, queen, right? Just store those values and give you back a string. Sure. So you can get a string version of your card. Get the value as a string, get the suit as a string.
Less than 5.12, the student example, would that run if you popped in the code?
Yeah, student should, because it didn't use the JavaFX stuff. So just that circles here with JavaFX isn't going to run for you until you do all the JavaFX stuff. Yeah, the other stuff should run just fine for you if you pop it in. Right, and then building it all together, putting a little card game together. He does his whole example kind of putting it all together, right? So there's a score for this game. We play. Well, all right, well, what is play? So we have to go look at the play method. So play. So, okay, let's make a deck. You get current cards and next cards. You have to guess what card it was. Sure. And then you can shuffle the deck. We'll get a card, right? Deal card is my current card. Here's the first card. We're going to loop as long as something's true. You're going to guess if the card will be higher or lower. Sure. If it's higher or lower. If your guess was not higher or lower, loop again. And he does a do loop. I hate do loops, but sure. There's a semicolon here. It irritates me. That's fine. And then you deal the card. Here's the next card. We find out if your value is the same, you lose. If your value is higher than and your guess was higher, you win. If it was higher and your guess wasn't higher, you lose. Right? We're just kind of looking through, seeing what it's doing here. Otherwise, if the card wasn't the same, it wasn't higher, it must have been lower. If your guess was lower, you win. Otherwise, your guess was wrong. And it just loops forever. This is a very boring game, but just a way to interact with classes, right? I get cards from the deck, right? And I can look at the card values. Sure, I don't even think this does anything with hand. I don't know why you have the hand class, but sure. So just kind of putting all those pieces together, right? Deck is a noun, hand is a noun, card is a noun. Sure, we didn't end up using hand, but we thought about it. We could use hand if we wanted. We didn't need to for this, right? So as we think about problems and solutions, we can think about them in an object-oriented manner to try and solve them a little easier here. All right, so I got 8 o'clock. Why don't we take another break, and then we'll come back and we can pick up a lab exercise, and then we'll call it a night. Okay? All right, cool. Let's take 10. Come back in a little bit. I gotta get out of this room. It's here. I don't know why. You know, that's solving a problem. Think about it. I like that. I also don't want to hit that. It's 23. You just got to keep a room a decent temperature. Alrighty, I went a little over there. We got to talk about our lab exercise, and then we can get started. Alright, so let me go create a new link here. Excuse me. I'm going to get some more Coke here. The doctor told me I do have to lay off on the caffeine, and I was really sad. I know, that's depressing. This is lab 5. Lab 5. Java template. Grab this one here. All right, and D2L.
I want to smack him with them. No, he likes now that he can use my programs just for random shit. He's like, let's see if you actually did your homework, honey.
Nice. All right, so lab 5 here. This is for classes. So I'm trying to have these due at 11:59 p.m. again. The goal is that they're done before class starts next week. But if you need a couple minutes, right, I usually try and go over the solution beforehand. You know, you got stuck on one or two things, great. If you got none of it done and you showed up and you copied my answer, you're hurting yourself, honestly, because the lab is to make sure that you understand the material. Right? If you're a whole week behind, you're going to be lost the whole next week when I'm going over new stuff here. So let's try not to have that happen. Again, the labs are not really a big part of your grade. They're for your practice, for your checking. Am I getting this stuff done here? So if it happens, it happens. You know, it's not the end of the world, but you don't want that to be the habit because it's just bad for you. And when you get to projects, you're going to be super confused. So that's sort of the idea there. Please submit the URL to your repository. All right, make sure this is a text submission. Cool. All right, so we're going to write a class for, what do we want to write our class for? Let's make our class, what do we want to have for bottle? We're going to include attributes for max volume in milliliters. Right? Anytime you're dealing with a unit of measure, you have to tell them what unit we're using. Right? Ounces are stupid. Our system is terrible. So we're going to use milliliters because it's better here. So we'll have attributes for max volume milliliters. This is probably an integer, right? As an integer, because you probably don't need half a milliliter at that point. I don't even know if you can, like, a dropper only measures like milliliters usually, right? So that's probably precise enough. And we'll have a current volume in milliliters as an integer, right? And then we'll have a string for, I don't know, beverage name or something like Coke, Diet Coke, coffee, water, soda, I don't know, whatever you want to call it here. Yeah, that's our bottle, right? Beverage name, right, as a string. Okay, so those are our private instance attributes, right? We're going to have methods include a default constructor, and a constructor with parameters. This idea, so I can make a default one, here's my default values, and I can make one with all the arguments right here, so I don't have to call all the sets. Both ways are fine. We'll include get and set methods for the attributes. Again, the tool will do that for you, right? Use the generate option. The tool actually will write your constructors for you too. If you go to generate, you can say, I want to generate a constructor. Now, and you pick which attributes you want. And we already have one that does this, but it'll make one with all the attributes, or you can have none and have a constructor with no arguments. Right? Works perfectly fine. I don't think it actually changed anything to it. Okay, yeah, we just added that for name. You right click and you go to generate in your class. So you have, no, oh shoot, don't, oh goodness, stop. None of these things. Oh goodness, I clicked the wrong buttons here. View commits, I don't want, nope. No. Oh my goodness, go away. Stop. I don't know what I clicked on. Close annotations. There we go. And then I don't want that one either. Oh, I want my run though. I want the run. There. I think that's what I usually have, right? Does that look right?
Yep.
No, I usually have project open though. There. And project. I get upset when my window doesn't look right. I'm sorry. I'm particular. I lost my train of thought here. Oh, in your class, you have to list your attributes first. Then you can go generate stuff. So list your attributes, then you can generate constructor, getters, and setters. Works pretty nice here for you. Okay, for the attributes. Then we're going to add a method for drink. that accepts an argument for milliliters to drink. Milliliters to drink. Right? You're going to make sure you have enough current volume to drink. Volume drink. Otherwise, return false. If you have enough volume, current volume, subtract the milliliters to drink and return true. Right? Just like our withdrawal method. Right? We're not reinventing the wheel here. It's very similar. Do I have enough to withdraw? Do you have enough to drink? If you don't, tell me no. Otherwise, drink that amount, right? Reduce your volume by that amount and return true. It worked. Okay. And then we're going to add a method for fill that accepts a milliliters fill. Ensure you don't or you won't overfill the max volume. Return false if you will. And don't add the milliliters to fill. Right? Otherwise, add the milliliters to fill to the current volume. So this one's a little different, right? We didn't actually do this one yet. So in this case, we're still checking. We're still going to give you a true or false if it works or not. But your amount to fill plus your current volume can't go over the max. Right? Otherwise, you're going to spill pop all over the place and do a big sticky mess. We'll say no, just don't do it. Just stop. Right? Otherwise, add the milliliters to fill to your volume, your current volume. Right? So sure, you want to add 50 milliliters of Coke? Add 50, like pretend you've got that soft serve or no. My goodness, self-service, right? Pop machine. Just go, put my bottle over here, filling it up 50 milliliters. Great. We're good. Okay. That makes sense? So what we don't want here is except for a set current volume in milliliters. So don't have a set current volume in milliliters because the way we're interacting with your current volume is by drink and fill. Okay. You can set the other ones. So setting the max volume, just pretend like you're modifying the bottle or something. I don't know. It probably doesn't make sense, but that's fine. We want to be able to change that one. So just to make it fun. So you can make your bottle bigger and smaller if you want. We'll just stretch the plastic, or it doesn't have to make a whole lot of sense, right? But maybe we do duct tape. Duct tape can fix everything, right? Poke a hole in it, add some more plastic, duct tape it together. Or flex tape. We just need some flex tape. I hear that works. All right. Constructor. There we go. Parameters. Right, does that make sense what we're doing? So very similar to bank account, but now this is bottle and we're filling it and drinking from it. Okay, instead of depositing money, withdrawing money. All right, so that's our lab exercise for today. We can get working on that one. All right, due next week. All right, awesome. All right, folks on stream, I think I can end the stream. I'll be wandering around the room. Shoot me a message. I'll try and keep an eye on Discord. I've got that on my phone, so if you shoot me a message on Discord, we can hop on a screen share if someone of you got questions. Thanks, everybody.